Okay. Now we are moving into a little bit more chemistry. Okay, still terminology. We need to know about the types of chemical compounds. You're going to learn about three main types of chemicals: ionic compound, molecular compound, metallic compound. Right? There are three types. Our focus was atoms, molecules, ions. Right? So same idea. Right? We have ionic compounds made up of ions, molecular compounds made out of atoms, neutral atoms combined by covalent bonds, and metallic elements combined in a communal pattern. That means they are all metal atoms in a metallic structure is connected to everything through sea of electrons. Metallic properties are different. So we're going to talk about that. This is really foundation to your calculations. Now let's look at this. Atomic elements. Atomic elements is one atom. Element means atom means one atom. Elements mean only one type of atom. There are atoms of only one kind of element. What are the examples? Atomic elements are only noble gases. Okay, in the periodic table, naturally they don't occur except the noble gases. Do you understand what I mean? All the helium, neon, argon, krypton, xenon, radon, right? They have only one atom, right? That's called atomic element. There are only that. But the rest of the elements, non-metals, like nitrogen, oxygen, chlorine, bromine, iodine, phosphorus, sulfur, they will be molecular elements. What do you mean molecular? Molecular. A molecule, right? See, what is the difference between generally an atom and a molecule? Atom has only one atom, okay? Monoatomic, right? So these could be diatomic, triatomic, okay, many-atomic, right? So, for example, oxygen is diatomic. It's a molecule, all right? Oxygen is a molecule. Sulfur is a acid. In sulfur, there are 8 sulfur atoms, okay? So, things like that. Phosphorus has P4, right? 4 phosphorus atoms. Okay, nitrogen is what? 2, okay. Let's look at other things. Sulfur is 8. Bromine is 8. Bromine is 8. I'm asking how many atoms in the bromine molecule? All that halogens are diatomic, right? Molecules. Chlorine is what? What is chlorine? Is it just chlorine? Element is, when you have chlorine gas, what you have? Cl2, Br2, I2. Now rest of them are most of the black ones, which are solid. On the metallic side, they are metallic elements, right? Metallic elements. Now there's a difference between atomic element, molecular elements, or metallic elements. What is the difference? They have different properties, okay? Of course, if it's sulfur, calcium, chloride, calcium chloride is this. Remember, we didn't use calcium dichloride. Why? We used prefixes only for covalent compounds, or in between, this in the area where semi-metals, all right? Okay. Now, what the idea is, molecular compound is covalent compound. Ionic compound is not a molecule. How many of you see this? In an ionic compound, there's no molecule. You can define in your verbally, molecule is two atoms or something, two different atoms. You have to say molecule is a neutral atom, neutral collection of two different elements, right? There's no ion there. So there's a distinct difference between formula, molecular compound and covalent compound. What is a molecular weight? Give me an example. What compound have molecular weight? Molecular compound. Pick one molecular compound, then tell me what that molecular weight is. Let's pick water, okay? What is the molecular weight? How do I get 18.02? 99, okay? That's how you got. These are grams per mole. Then there's a grams per mole. That's how you get the mole. Right. This is called molecular weight. Now, molecular weight is only for molecular compound. What is the formula weight? Ionic compound has a formula, but it's not a molecule, right? You could have called it formula, but we use formula for formula weight for like sodium chloride, calcium chloride. You can calculate the right. When you calculate the this is called formula weight. This is called molecular weight. But together, if you have molar mass, molar mass is a general word for any. If you have the formula, you calculate the mass of the formula, right? I'm not telling you formula weight, right? Molecular weight or formula weight. If you take that in grams, you get a molar mass, right? Okay. How many of you got the idea? Molecular weight is for molecular compound. Formula weight is for ionic compound. Don't call it molecular weight of sodium chloride. I mean, it's okay, but it shows that you really don't know what you're talking about. There's no molecule, right? So I try to correct it because it may not be a big deal, but on the long run, you have to know what you're talking about, right? Now, in this chapter, what we're going to do is talk about ionic compound. Then your second homework, we're going to talk about these molecular compounds and the acids. Acids are molecular compounds, but hydrocarbons are molecular compounds. They have different systematic naming, right? So we're going to look at that. So first we do the ionic compounds. Now you already know ionic compounds have type 1 and type 2. Okay? Let me go to the bigger picture. Here. So we're going to do naming ionic compound formulas and all that, and the molecular compounds, then the acid name, right? So that's the flow of ideas. Metal form only one type of ions. What is that? Type 1. metals form more than one type of ion. It's called type 2. Normally what you have is, they're similar, but you have to, when you give the name, you have to put a parenthesis at the metal name and tell what exactly that charge is, right? For example, in here, chloride is -3, -1, -1. There are 3 of them. Therefore, chloride together have 3 negative, right? So therefore, what is the charge? What should be the charge on neutral formula here on Fe? +3. It has to neutralize. Formula has to be neutral. You cannot have, otherwise it's formula weight or it's a formula of ion. Okay? All right. So these 3 has to be written down as Roman numeral here. But here, there's no thing. Calcium iodide. Now, one thing, all metals keep their name. They don't change name. This like male, female thing, you know. Remember when you get married, you change, the girls change their name to the husband's name, right? Some people keep it both, okay, that's okay. Now, do you understand? Metal don't change the name even they become ion. We call it sodium ion. We don't call it sodium ion or anything, we call sodium ion. But chlorine become what? Chloride. Fluorine become fluoride. Oxygen become oxide. So you add I. Same rule for the both, right? You see that? So therefore, non-metal name is changed the last letter. Chlorine, drop the E, chloride. Ionic compound, molecular compound. So some inorganic compounds are anorganic compounds. Inorganic means like sulfuric acid, right? Sulfuric acid has H2SO4. That's covalent compound. HCl, hydrochloric acid. Organic is halogens, alkanes. Acids and bases, like ammonia, acids, okay? Hydrated compounds. You have sometimes a water molecule trapped in the solid. For example, copper sulfate, we call it pentahydrate. You put a dot in between, you call it pentahydrate. Even molecular compound can have hydrates, right? What is a hydrate? A compound with extra water, right? Hydrate means, hydra means water, okay? Extra water. So we're going to look at this now, starting with ionic compound. Now, ionic compounds are formed between metal and a non-metal. This is the sodium atom. Sodium atom is, which atom is bigger? Sodium atom or the chloride atom? In fact, if you look at this, chlorine is smaller than sodium. Why is that? Because going across the periodic table in the same shell, right? Period. Number of protons increase, right? It contracts, right? That's the trend in the atomic sizes. Going across the periodic table, the size decreases. Anyway, sodium is bigger, but when you lose the electron, it becomes like what? Neon. Neon is smaller. Now, chlorine is, even though it was smaller before, when you gain an electron, one thing you have to notice is, when an atom gain an electron, they expand. There are same number of protons, right? Now many electrons in the valence shell. You're going to talk about this in 101, all right? I'm just giving you some idea here. Now this is the chloride ion. Which one is chloride and which one is sodium now? So this is the snapshot here. This one, this blue one is what now? Sodium. It's a smaller ion. Chloride is the green ion. All right. So that's how the ionic compound is formed. Lattice of the ionic compound. Ionic bond is metal, non-metal, composed of ions, cations and anions. Summary. Non-volatile, thus high melting point. Why this sodium chloride, okay, is so, why is always a solid? It's not a liquid unless you heat it up to 700 degrees Celsius. You can melt sodium chloride, very high temperature. Because what is the reason why they are solid? Ionic compounds are solid, non-volatile. Non-volatile means, I don't know whether you ever smell sodium chloride bottle or something. Can you smell it? Even the sugar you cannot smell. You know, I tried. Because they're solids, right? There's no volatility. Like if you ammonia bottle, it hits your brain right there, right? Ammonia is a vapor, right? So, you know what? That's how people get addicted to drugs. Like pens, you know, they smell all this in the school, right? So, I don't know, you can get addicted to something, you know, you're different from everyone. Solid do not conduct electricity, but melted liquids. So ionic compounds conduct electricity when melted or soluble in water. If you do put something in the water, ionic compound will conduct electricity. Here's the idea, I should have bought it. You have a little gadget, that's the electrode with the cell. If you put sodium chloride, this bulb lights up. If you put sugar in it, nothing. Why? There's no ion, all right? So if you put some bases, which are weak electrolyte, like ammonia is a weak electrolyte, it produces a little bit of ions. This light bulb will be glowing really little. Weak electrolyte have a less glow, strong electrolyte has stronger glow, non-electrolyte have no glow. Okay. Non-electrolyte, listen. So we can tell what compounds are ionic, what compounds are molecular, all right? Now I'm going through this again and again. Type 1, type 2, all right? Okay, I'm going to get a periodic table and show you where type 1 are. Where the type 1 are. Fixed charges, these two, aluminum 3 plus, 2 plus, 2 plus, silver is what? 1 plus. Even though they are transition metal, they behave like what? Type 1. We don't call silver 1 chloride, all right? Cadmium chloride, we don't call cadmium 2 chloride, even though it's there. But we call mercury 1 or 2. Mercury could be +1 or +2, right? Gold could be +2 or +3. So therefore we need to know where you find the charges is in the name. The name ion 3 tells you what the charge is on the ion, right? But for type 1, you don't have to do that. Okay. Now these are kind of a semi-metals. Sometimes we use different use. We treat them as metals, non-metals sometimes, okay? So therefore it's kind of messy there down there, but clear, type 1 and type 2. Type 2 include lanthanide. If you we have a problem later, like what is the name of this compound? The wrong one. What is the name of this compound? It's a type 2. You have to tell the parentheses what it is. Oxygen is what normally? The oxygen is 2 plus, 2 negative, 2 negative. It gained 2 electrons, right? There are 2 of them. Total charge on oxygen is what? What is the total charge on 2 oxygen atoms? Ions? 4, right? This what I'm talking about, okay? This together. So uranium 4 oxide. Okay. If you see anything in these groups, right? That middle group in here, except zinc, cadmium, and silver, tin and lead. We hardly deal with these. Tin and lead is fixed. Also type 2, no fixed charges. Charges of the some metals. This is from the book. Manganese. This is the prominent charges. Cadmium is always 2 plus. Mercury, mercurous, chromium. This also behave like. This also can form +4. This is a common oxidation state. Non-metals form negative ions: oxide, nitride, carbide, sulfide, selenide, telluride, iodide. See that? Then you can form metal, non-metal combination.
Why does mercury have all those 2s? Like, I thought you said mercury had 3 or 2.
This is 2 plus.
Right.
There are 2 of them, therefore one of them is +1.
Okay.
So +1, this is kind of what we found. It's exists at Hg2 2 plus.
Right.
So therefore still the oxidation number is number of charge on the ion. Oxidation number we call it is 1, right? That's 1. Monoatomic ion, type 1. How do you get the charge? You look at the periodic table, right?
Right.
Okay, group 1A, what's 1? Group 2A, that's the second. Non-metal. 8 minus group number. Then that means group number is 8 minus group number. 17 minus, no, that's not right. Group number is 7A. 7, we will use 7. Group B number, 7B. B7, whatever it is. 8 minus 7 is what? 7, group number, okay, 8 minus group number, -1, right? They form, look this way, it's -2, -3, right? Going this way. For non-metal, you start from here. Metals, you start from there, right? Some people always go from this end to that end. You know, hey, charge on the fluorine is 7. Okay? But they're not losing electrons, okay? They're gaining electrons. When you gain, you move this way. Lose, go backwards, right? Okay, monoatomic and type 2, transition metals, have ion with different charges. Ion could be +2 or 3 plus. All right. Now, we also need to know about polyatomic ions. Polyatomic ions. Now, I can talk about this. I can tell you what the charge is. Unless you cannot do it, there's no point. I can show, hey, you ask me what the charge, the name, I will tell you what it is, okay? You have to go through this, right? At least until you get over this test, right? You have to remember these things. Perchloride ion, chloride ion, chloride ion, hypochlorite ion. Okay, sulfide. If you have sulfate, one less oxygen is called sulfide. Hydrogen sulfate, hydrogen sulfide. Dichromate, ammonium, chromate, nitrite. Nitrite has less oxygen than nitrate. Hydroxide, bicarbonate or hydrogen carbonate. Carbonate, carbonate ion is CO3 2 minus. And then acetate. How many of you have heard about acetate ion? What is the formula? C2H6O2? H3O2. All right, acetate ion. Now, what is the bisulfate ion? What is the formula of bisulfate ion and the charge? Sulfate, bisulfate means hydrogen sulfate. Okay, I'm just giving you that. You have to remember the hydrogen sulfate is big. Okay. Now we are going to use whatever we learn here. Identify the type of ions in the following list. Cations of type 1. Tell me what are the type 1 ions. Okay, what are the type 1? Okay, type 1 mainly fixed charge, right? Fluoride is fixed charge or variable charge? Fixed. Okay, start with fluoride. How about Fe3? Fe3 plus? No. Calcium? It's a type 1, right? Okay, what else is? Cations. Okay. I'm not going to write down hydronium ion, okay? Barium 2 plus. Barium 2 plus is alkali metal. How about chloride? Chloride is also. How about, I am writing down only monoatomic. Copper? No. Strontium? Radium? Okay, nickel? No, because it's a type 2. Bromine? Bromide? Okay. Chromate is a polyatomic ion. We don't talk about any of these. All right? So these are the type 1. All right? Now, A is the answer to that. B is type 2. What are the type 2? Fe2 plus, Fe3 plus, what else? Cu2 plus, 1 plus, Cu2 plus, nickel 2 plus, nickel 4 plus, plus 4 plus, 4 plus. Okay, what else? Right. These are polyatomic ions. Now, monoatomic ions.
It's like
Monoatomic anions. What do you say? Huh? You didn't get that one?
No, I got it.
Okay. So what did I say? You have a question? I hear something big. So, am I hearing voices now?
I'm just in the hallway.
Oh, okay. I was so absorbed in this. What are monoatomic ions? Fluoride, bromide, right? Monoatomic. Monoatomic is only one atom. Okay, what is polyatomic ion? Polyatomic anions. D. What are polyatomic anions? Chromate ion, CrO2, 2 minus. Dichromate ion, CrO2, 7, 2 minus. Manganate ion, MnO4 minus. Oxalate ion, oxalate. Oxalic acid is in food and drink, sometimes oxalic acid, and that oxalate ion. All right, that's it. Now E, polyatomic cations. These are anions, right? What is that? Hydronium ion. You heard about that hydronium ion? Hydronium ion is in water, okay? What else? Ammonium ion. It's a polyatomic cation. Is there anything else? No. Now, I'm giving you some examples of you should do. You should be able to find these individually, separately, as a collection, all right? Polyatomic is more than one atom, but there's a charge, has negative charge, except for ammonium ion. See, ammonium ion and the hydronium ion, okay. Negative charge range from -4 to -1 to -4. There's a table in the book and in the slide. Okay. Now let's finish this one today. Give the name of the following ion. What do you write down here? Chlorine. An ion name is changed, right? Like I said, when you get married, remember that thing? Okay. Chloride. That's called sulfate. This is called less oxygen is called sulfide. This is called iron 3 ion or Fe3 ion, right? Okay, let me write down. Okay. Sometimes we write ion. If it is ion alone, we write ion 3. Like what is that? Sr2 plus is called strontium ion. We have to write down ion, okay? Chloride ion, sulfide ion, sulfate ion, ion 3 plus 3 ion, strontium ion. You don't call it 2 plus. Carbonate ion, carbonate. Nitrate ion. What is this one? Phosphate ion. That one, mercury 2. Okay, now let me tell you about this story. Mercury plus and mercury 2 plus. That's called mercurous. Mercury. Okay. Now E is the whole system. S means less charge. E means more charge. Ferrous, ferric. What is the ferric? Ferric is 3 plus, all right? Ferrous is Fe2 plus. So there are all naming. We stick with new naming. Dichromate ion, permanganate ion. What is this? Oxalate ion. You guys are, oh yeah, all right. If you say so, right? What is this? Ammonium ion. All right. Uranium, what? 4 ion. Why uranium has to be parenthesis 4? Because it's a type 2. Hydrogen carbonate or bicarbonate, acetate ion. Hydrogen sulfide ion, hydrogen sulfide, bisulfide ion. Hydrogen phosphate ion. Oh, yeah, there's a 2 negative here. I'm sorry, okay? There should be a 2 negative here. This is okay. Dihydrogen phosphate, all right? Dihydrogen. Phosphate is 3 negative. When you have 2 hydrogen, which are plus each, all right, it neutralizes. All right. Okay. I'm tired now. Now, often you need to name these things. We already done this. Okay, I want you to name these. Okay, how do you name these? These are oxyacids of chloride. Okay, there's a series of oxyacids. Okay? Now, you start with the middle one. This is called perchloric acid. No, chloric acid. Okay. Now, this has 1 less oxygen in there, HClO2. What you would call it? Ik. What is the lower mean? Us, right? Remember we use lower, whatever lower is 8I, okay? Like ik means us, right? Now if you look at these two are coming from this. This has more oxygen than chloric acid. What do you call it? Now like sugar levels in your blood. Hypoglycemia. Perchloric. What do you mean by perchloric? It has more oxygen than chloric acid, right? Then this is called hypochlorous acid. What it means is hypo means less, right? Okay, there are 3 acids of hydrogen is called oxoacid of chlorine, hydrogen, and oxygen, right? Oxoacid always have hydrogen and oxygen plus another element. Sulfuric acid is oxoacid. All right. So each one of these has 1 acidic hydrogen. Now, if you remove the acidic hydrogen, it comes out as a proton, right? Acid means proton. Okay, you get this. What is the name of this ion? Hypochlorite, okay? Us means less, I. Okay, this is called hypochlorite. This is going to be chloride, ClO2 minus. ClO3 is perchlorate, chlorate. hypochlorate. Now these are all ions, okay? ClO4 minus. Ion, okay? Ions. Alright? Now if you look at this one, what is the name of this acid? Ion. It's coming from hypochlorous acid, right? What is the name of that ion? Hypochlorite ion, right? Hypochlorite. I think in the thing here, I wrote down hypochlorite. This one is chloride. This one is chlorate. Perchlorate. The acid formula is HClO, HClO2, HClO3. We wrote down in here, right? Do you see that in the paper? Okay. And this is HClO4, that is perchloric acid. Chloric acid. What is this one? Chlorous acid. Hypochlorous acid. All right. Now we extend this argument to similar compound. Okay? Chlorine. This is iodine. Iodine. What should be the name of that? This has to be hypoiodide. Hypoiodide. Higher there, this not hypo. This is going to be iodide, right? This is going to be iodide. This is going to be periodate, right? You only, that chloro part, you put the iodine part, right? Iodo, chloro, right? So it's given here. You see that how I got it? Now I want you to write down, not just be, I mean, whatever I do, sometimes you guys, okay, you did it, I don't have to do it myself, right? Not true. Because if I know about it, doesn't mean you know about it, okay? How do you get it into your mind is, you work with it, right? You write down on a piece of paper, right? Looking at the formula. If you have a problem, then go back and see whether you got it or not. Okay, if you're not doing it, you're not doing right. Okay, that's your choice, right? None of us going to be coming at you, right? Because it's your responsibility to take care of yourself. Okay. All right, we got this part. What is this one? Sulfate. Then this should be selenium selenate. Okay, selenate. Selenate, but it has to be selenate. S-E-L-E-N-A-T. Selenate. What is this? Iodate. This has to be bromate. Chlorate, bromate, iodate, right? So any combination of these has to be remembered. Now I gone over this Roman numeral and all that stuff. Okay. Now I told you to get the formula between any of these combination. How do you get the formula? How do you get the formula? If you want a compound between sodium and oxide, you write down sodium plus, oxide 2 minus. Then you look at the charge balance, right? Is it balanced? It's +1, 2 plus. I'm not asking atom balance, charge balance. Charge is 1 here, 2 here. How do you make it equal? You cross multiply. Okay, Na2O. That's the formula of this. Now this person that I gave the paper, in her paper or his paper, he write down like this, right? Like this. But then didn't remove this. Okay. Normally in a formula of ionic compound, we don't write the charges. All right. She had the idea, but you have to take them out. All right. So that's okay, but that person had it. What is the compound name between magnesium and nitride? Nitrogen. From this. This is 2 plus, this is 3 negative, right? 3 negative. How do you get the formula? Now you cannot, if you have both two different numbers, you have to cross multiply, right? So it has to be, normally we do it if it's not equal. And that's magnesium nitride, right? Nitride, like that. Okay. Now, just quickly go through this. I'm not going to write down. We'll talk about it. Tell you about it. Sodium chloride, right? Iron 3 oxide. Why iron is 3? The charge is shown up on the next, because it's a type 2, iron 3 oxide. Ammonium nitrate, both negative, negative. Potassium, what is the rest of it? Perchlorate. Perchlorate. Not here. Dang, I made a mistake there. Perchlorate. Hypo is the potassium perchlorate, all right? Perchloric acid. Calcium, what's that? Carbonate. Ammonia, sodium hydroxide. Silver nitrate. Okay, mercury is 2 plus here. Mercury 2, what is that part? Acetate. Cobalt 3 sulfate. You see, why is cobalt 3? The charge is in here, we cross it, right? Okay, potassium iodide. Magnesium nitride. Sulfide, oxide, nitride, selenide, okay, right, all I. Chloride, bromide, all these charged anion. Okay. Now this one. Now let me tell you how you get it. A couple of them. I'm not going to do every one, each one of them. I have the answers here. When you have the formula, like silver carbonate. Yeah.
Yeah, you named both the ClO3 and ClO4. You named both before.
Didn't I? I don't see it, okay? All right. Good one. Did you get it now? What is hypochlorite? Chloride, chlorate, perchlorate, right? That's all that matters. Now silver, carbonate, Now, to get the formula, you need the, what do you need? Ions. Always charges of the ion. What is silver? Silver is a type 1 of, even though it's in the transition metals. Did you remember what I said? Even though it's transition metal, silver, cadmium, zinc behave like type 1, right? Silver is +1, cadmium is 2 plus, zinc is 2 plus, right? Okay. Silver, what is the charge on here? 1, right? Now carbonate is this. What is the charge on this? -2. Now charge is not balanced. So what you have to do is simply multiplying this by 2, okay, and crossing it will do silver to carbonate, okay. All right. So let's see whether that person got it right. Yes. See. Now, she normally write down like this: plus and CO3, 2 minus. That's okay, but you have to drop these after you write it. Okay. Now, what's that? What? Tell me what?
The same thing with the stuff that you do. It's not the same thing.
What's that? No. Oh, no. But there's no 2. I made a mistake. Now, when you do multiply, there's no 2, okay? Cross multiply. Thank you for showing this, right? You helped me out, okay? Okay, now this one you don't need this, all right? Okay. You multiply this. Okay, let me show you. You multiply this, and it came down here, right? You multiply this, it came down here. That's 1 is not going to be showing up, right? So therefore, silver carbonate. Got it. Okay, second one, potassium hydrogen phosphate. I'm going to write down potassium is this, okay? Hydrogen phosphate is this, 2 minus. Agreed? Potassium hydrogen phosphate. Now the formula has to be 1, 2, K2HPO4. Does that person have it? No. There's no 2, right? Okay. Now can you correct that one? Okay. K2HPO4. Now the other one is aluminum hydroxide. Aluminum is 3 plus. Hydroxide is what? Okay. You cross multiply. Aluminum is 1. Then when you have a polyatomic ion, you do is that, right? 3, right? For the whole thing, sodium bicarbonate is correct. Why is sodium bicarbonate is correct? Sodium is +1, bicarbonate is -1, right? I think we gone over this one, right? We already done. Group homework. Which group homework is this? 7?
7.
Right. Okay. Now, we're going to talk more about formula. Okay? There are many types of formula. One is molecular formula for molecular compounds. Empirical formula. And later we're going to look at condensed formula. and then structural formula. Formula. Okay. Now let me give you an example. Pick up a simple compound, H2CH, ethane. That one is giving the simple ratio, not the simple ratio of the atoms in the compound. Normally, if you have a formula, you write down the element and subscript, it tells that how many atoms of the elements are there, all right? But sometimes molecular compound can have a simple formula like this, CH3. That means twice. That means a factor of 2, right? So empirical formula in this case is CH3, simple ratio of atoms, all right? 1 to 3, we talked about it. So condensed formula is, it gives more details about how the atoms are bonded. This is written like this. That means there are 2 carbon atoms bonded to each other, okay? And in turn, these carbon atoms are bonded to 3 hydrogen atoms. Right? The structural formula is details of bonding, much more details of bonding, expanded. The condensed formula expanded, you get the structural formula. Structure means with the bond, right? So there are things. Now we talked about this. Did we go through this distinct empirical formula? Yeah, I think I did, okay? Now one of the things you need to do in looking at a molecular formula, this is called molecular formula, it's a molecular compound. If it is ionic compound, we call it just formula, ionic formula, right? Ionic formula. Now looking at that, how many atoms indicate the type of atoms and number of type and atoms in the molecule? How many in here? What do you write down? How many carbon atoms? Okay. 6. How many? 12. That's very simple, right? Okay. What is the molecular formula? Molecular formula is normally what is given, right? Sometimes it could be a empirical already, but we don't know. Right now, this is not empirical because you write down C6H12O6 here. This is glucose. What is the empirical formula? Empirical formula is the simple ratio of atoms, right? What would that be?
CH2O.
Okay. C6H12O6. You find a common factor. What is the common factor? 6, right? 12 up to, and you multiply by 6, then you get that. That the factor is 2. Therefore, empirical formula is simple ratio is 1 to 2 to 1. We don't write that way. That's the empirical formula. Now, one thing you have to understand later: ionic compound always has empirical formula. Simple ratio, sodium chloride, calcium chloride, right? They don't have multiple of formulas, okay? Multiple of these numbers. Now, we are naming molecular compounds. Now, it's similar to naming ionic compound. We use the same thing without with the prefixes. Ionic compound, you don't use prefixes. How many of you got that? Ionic compound, no prefixes. Here, ammonia, water. Now there's a problem. There are two types of names, systematic and common name. What is this? Systematic is there's a rule to get the name, okay? But common name is, you just give a name anybody, like Baba. You don't know why you give it, okay? So the water is called water. It's been called water forever, agua, right? So those are the ones we use for common chemicals, all right? Ammonia. Water should have been named what? Systematically. Dry hydrogen oxide, all right. Ammonia should be what? Trihydrogen nitride, right? Okay. Then these are systematic names. Nitrogen monoxide. Sometimes it's called nitric oxide, dinitrogen oxide. Now, why is nitrous? Its oxidation state is lower. Oxidation. We're going to talk about this later. If you look at this, okay. All right. See that has this. Therefore, each nitrogen is +1. Okay. To cancel out. All right. Formal oxidation state. We assume they have kind of electrical balance themselves, even though they are not ions. It's called formal oxidation. Now in this one, NO, this is 2 negative, there plus this higher charge for the nitrogen. Nitrogen in this case behaving like a metal, all right? But there are no ions. Therefore, it's called nitrous oxide, nitric oxide. We use that same higher charge is ink. Remember, nitric, ferric, right? Dinitrogen tetroxide, carbon monoxide, carbon disulfide, sulfur trioxide, carbon tetrachloride, phosphorus pentoxide, pentachloride, sulfur hexafluoride. All right? See, we use prefixes. Not for the, if it is 1, the first element is 1, you just ignore it. Just say the name of it. Okay. Give the systematic name of the following binary inorganic compound. These are considered inorganic. Even carbon tetrachloride is considered inorganic because organic is carbon containing compounds, mainly which are associated with living systems, right? Organic. Derived from or coming from living systems. Carbon tetrachloride could be produced synthetically. Most of it is produced synthetically. All right, what is this? Water is dihydrogen oxide. Okay, can you write down that there? Okay, A is dihydrogen oxide. Okay, B is, what is that? Hydrogen chloride, all right? We call it hydrochloric acid, but it's kind of a common name. Hydrogen chloride. All right. Sulfur hexafluoride. E, boron, trifluoride, E, what is that? Dinitrogen tetroxide. F, carbon tetrachloride. G, sulfur trioxide. The second name is always element name is changed to I, right? H is phosphorus trichloride. Okay. Now you have to identify metal, non-metal, non-metal. Then you know you have to use the prefix for the second name, second element, right? All right, got it. Now the hydrocarbon has its own systematic procedure, its own procedure. Now, there are, I didn't bring my model here today. I will sign this. Okay. Carbon can bond to 4 atoms, right? Carbon. The first hydrocarbon is carbon-hydrogen compound. Hydrocarbon is this. There's no other carbon. It will bond with another carbon atom. That's the structural formula. This is the condensed formula. All right. Now, this is the molecular formula. Oh, condensed formula is this. Molecular, structural, condensed. Now, like that, you can increase carbon chain. If you keep on increasing at one end, another carbon, another carbon, another carbon. Now you have how many carbons? 1, 2, 3, 4, 5, 6. 6. We know 6. 12 plus 2 is CnH. 2n plus 2 is the number of carbon hydrogens. All right. This is called a straight chain. But you could have a 3 carbon atom here. And you start to branch. All right. Okay. You get branch alkane. Regardless of branch or straight, formula is always same for alkane. What are the characteristics of alkanes? They are carbon-hydrogen compound. They could be straight chain, branch chain. They always have the formula CN H2n plus 2, right? All right. Now, alkene is something which at least one double bond is inserted in between. This is coming from ethane. Ethane is second carbon atom. It's called ethene. Now this is the systematic name. It's called ethylene. How many of you, this is common name, ethylene. Have you heard about ethylene? How many of you have heard about ethylene? No? If you work at Walmart, you probably heard it. Because they bring like a banana from green banana, then they put in a gas chamber, right? And they ripen it. all right? Good ripening, this has effect. Now, if you took out two hydrogens, like no two hydrogen there, therefore double bond. If you take out four hydrogen, that means triple bond. If you have a triple bond, it's called ethyne. The first thing is called, this is the ethyne. The common name for this is acetylene. What have you heard about acetylene? No? Where do they use acetylene? The welders, right? I had one guy came and fixed my air conditioner. He took out the condenser, then he had to connect those copper tubing. Then when I look at it, he has acetylene, oxyacetylene flame, is high temperature. So he heated up, put it there with the welding thing, with the stake, Acetylene is used for that. So you understand this is used for ripening fruit. Okay. The R group is a generic R. The letter R is used as a generic for any organic group. For example, C2H6, take out a hydrogen. That means C2H5. Then it can bond to many other compounds. It can bond to an OH group. Then we call it alcohol. There are many organic compounds other than hydrocarbons. Halides, right? Freon is fluorine compound. How many of you heard about freon? All right, like that, you have halogens, alkyl halide. This R group is called alkene. Methyl alcohol, ethyl alcohol, C2H5OH, like that. So we have many. The common name for that is ethanol. You heard about not common name. This is the systematic name. Ethanol means two carbon atoms. What is the common name for ethanol? Just alcohol, right? But don't drink anything with alcoholic name on it, okay? Because if you drank methanol, is it good? No, it's going to kill you. You go blind first, then your liver fails, It's a recipe for disaster, right? Give the common name of the following molecular compound. What is that? Ammonia. Now this one is, it says the molecular formula C2H, the molecular formula we normally write down, this is the acid. This part is called acetate ion, right? It's called acetic acid. The B is acetic acid. How many of you heard about that? Vinegar. Vinegar is acetic acid. Now you know what vinegar is. Have you tasted vinegar? Now my problem is I cannot keep my hands off things, Sometimes I like to taste. Not everything. But the vinegar is like when I make some marinade sometimes, things, the meat or something, you taste that vinegar, it's sour, right? Acids are sour. Okay, what is this one? C6H12O6. Glucose. It's a sugar. All right? Sugar. Carbohydrate, we call it. Carbohydrates are sugars, cellulose, starch, you understand that? All of them have the formula, CH2, empirical formula that. Carbon, hydrate means water, carbon water compound, right? That's why they call it. Okay, common name for that. This one is glucose. What is this one? The T. Alcohol. Normally common name for ethanol is alcohol. Right. So you got some idea about these things. Now, like I said, okay, acids are sour. They produce hydronium ions. Acid decrease the pH when you dissolve something. pH of water is, what is pH of water? 7. It decreases between 7 and 0 number. There are going to be binary acid. What is a binary acid? Hydrogen plus another element. Okay? HF, hydrofluoric, hydrobromine. H and a non-metal. Oxyacid. Give me an example of oxyacid. H2SO4, hydrogen, oxygen, plus another non-metal. Okay, this is H2SO4, H3PO4, phosphoric acid, chloric acid, and hypochlorous acid, hypochlorous acid, like that. Now, most of the acids have acidic proton. We normally write acidic protons in front of the formula of the acid, right? Monoprotic. Proton is the one that's coming out. Diprotic, triprotic, monoprotic, right? Acids have, right? Now acids also produce anions when the, okay, this one gives phosphate ion. This one gives sulfate ion. Remember we talked about hypochlorous acid, chlorous acid, chloric acid, perchloric acid. All right, so like that. Oxalic acid contains oxygen in addition to hydrogen and another non-metal. Okay. Hydrochloric acid, binary acid. That one is oxyacid, nitric acid, common name. These are common names. Otherwise we call it hydrogen chloride. Sulfuric acid, sulfuric acid. If you have SO3, H2SO3, it's called sulfurous, all right? One oxygen less. It means more oxygen. All right, chloric, boric, phosphoric, all right? So these are the names of acids. Acid gives anions. For example, hypochlorous gives hypochlorite. You change the hypochlorite, I, has to become I. Chlorous, chlorite. Chloride, okay. Chloride. All right. It become A. It become a perchlorate. Nitric become nitrate. Nitrous become nitrite. That's right. The other one is the swap. Okay. Chloride. All right. Now you got to know a lot of names now. Bases are counterpart of acids. Bases are bitter, all right? Bases, I haven't tasted bases. I mean, bases are kind of slippery things, like sodium hydroxide. If you get it on your hand, You had to wash it so many times to get your hands out. It keeps slimy, you know. It's bitter. I never tasted. All the hydroxides, all right? Ammonium hydroxide, calcium. What they have in common is OH ions, right? Acids have hydrogen ion, right? Okay. Now this is the problem. Okay? Now you have to do it. Okay. Name of the acid. What is the first one? A. Nitric acid ion is nitrate ion. Okay? Let me write down. I wish you write down yourself, not wait for me. Nitrate. Ion is nitrate. Okay, B.
Nitrous. Oh wait, B. No.
B is here. Okay. Phosphoric, right? Of course, acid. All right. You normally call it acid. Phosphate ion. Now, when you have more than one ion, one phosphoric has 3 acidic products. You can have 3 ions. Phosphate, what is the other one? Hydrogen phosphate, dihydrogen phosphate. You see, there are 3 ions. Phosphate is when if you remove all the ions, all the hydrogen. Now, nitrous acid, B. Nitrous. Nitrite ion. It's called nitrite. Now C. Okay. Okay, it's a D. What is the name?
Phosphorus.
Phosphorus acid. Okay. Phosphorus acid is PO3, 3 minus, still 3 acidic. So you're going to have hydrogen this is called phosphate. This is called, what is that? Phosphite. Okay. Hydrogen phosphide, 2 minus, and another one called dihydrogen phosphide, 2 minus. Right. Now that's the E. Sulfuric, sulfate ion, and what is the other one? Hydrogen sulfate ion. 1 negative. If you have diprotic acid, diprotic is what? How do you know diprotic? That in front of the formula that those hydrogen you wrote, okay? How many hydrogens that can come out, right? Okay, this is hydrogen sulfate, okay. F is hydrogen sulfate ion is HSO4 minus. Sulfate ion is SA, right? Now the other one, F, is what? That's a common name.
Bicarbonate?
Carbonic acid. Bicarbonate is the Ni, okay? How many acidic hydrogens are there? How many? Two, right? Bicarbonate, carbonic acid. Carbonate ion and hydrogen carbonate ion. Carbonate, correct. Now this one, G, is sulfurous. It's going to be same thing like sulfate ion, hydrogen sulfate, hydrogen sulfite ion, sulfite, sulfurous acid. Yeah, one less oxygen. They're not the same. Now, this one is acetic acid. Acetic acid. What is the ion? CH3 C double O negative or C2H3O2 negative. That's called acetate, right? Acetate ion.
How would you
Yeah.
how would you know that it was acetate, like by looking at it? Because it has 3 hydrogens.
Okay, this is kind of a condensed formula, okay?
Okay.
So that's normally how we write it.
Okay.
So this is the, like a CH3 is carbon bonded to that. That's called the carboxylic acid group. That's the acidic product.
Okay.
So that sometimes we abbreviate like that.
Okay.
So it's kind of something we do, all right? There are many complexities sometimes. When you look in books, then you begin to get that, or when you see different forms, right. Okay, we're going to go to, what problem was that? 6. Okay. Now, I was talking about this. There are molecular formula for molecular compound, which could be empirical. We also can write down that as condensed formula, which shows connectivity of central atoms, carbon atoms, but not the hydrogen atoms, like that. All right? Structurally, that's the alcohol. This one, expanded. It's very easy to expand this. Put 3 hydrogen on here, 2 hydrogen. Backbone is carbon, carbon, oxygen. Yeah. Okay? Normally in a condensed formula, if you have carbons are bonded to each other, or the other end. Then you expand the hydrogen on the backbone. Okay. Okay, this is the structural formula. There are ball and stick model. This, I had that molecule. That molecule looked like a dog. Yeah? Like I can turn it around like that and the oxygen is coming out on the head like that. Can you imagine that? Like an atom like this. Go like that, right? So I always make joke with this, all right? When you drink a molecule which looks like a dog, then you become a dog, right? I'm just, you got the joke. All right. Number 7. Given the structural formula for organic compound, write the following for this. Okay. As given, this is not structural, this is condensed formula. Can you correct that? Given the condensed formula.
Yeah, but I think that's usually the condensed formula.
I cannot save it. That's the. Do you understand this is condensed? Why?
Because it's expanded.
Like here, carbon. Right. Now, like that. What is the molecular formula of this compound? Okay, given the condensed formula, okay? What is the molecular formula? How do you get a molecular formula? Molecular formula gives what? Type of elements, right? And how many of each one is there? How many types of elements are there? Of course, carbon is there, right? Carbon is there. How many of carbon? 1, 2, 3. How many hydrogens are there? 4, 7. I agree with you. And how many oxygens? 1 chlorine, right? That's the molecular formula. Now, what is the condensed formula? Condensed formula is what is given, all right? It's CH3. Now remember, this group CH, okay, Cl, CH2, and OH. Now, why I'm saying this is that each carbon atom should have 3 groups. This has 3 hydrogen. Okay. Now this has 2, this has 3. The corner carbon atom should have 3 groups attached to it, right? Corner, because it's bonded to 1. The middle one should have 2, right? So this is the idea, but we normally don't write down that CH3, CHCl, CH2OH like that. Now you have to understand that how to uncode it, right? That's the condensed formula. C. Structural formula. How do you get a structural formula from condensed? You get the backbone, all right? Backbone is this, and OH, because this is attached. Okay, then you complete this with the hydrogen. I'm going to erase that one. Hydrogen, 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 hydrogen. Chlorine here. See? And 2 hydrogens. Okay, this is the structural formula. My H look like something else. Okay. All right. In organic chemistry, organic chemists become lazy sometimes. All right. They don't write all the carbon atoms. All right. What they do is they pick this like this. They pick these carbon centers draw like that. Each corner and the terminal is a carbon atom, all right? So then what they do is attach chlorine, there's OH here. That's the formula. Line formula. For example, benzene. Benzene is a cyclic compound. No hydrogens. No two hydrogens, hydrogen, hydrogen. Like this. This is called benzene. C6H6. Now, benzene is this. Double bond between. Carbon need to be bonded to 3 atoms. Here, hydrogen, quite right down here. Okay. That's how we write. It's much easier than writing there, right? This is a line angle formula. Line angle. Line angle. Line formula is called line and angle. Angle in single bonded carbon atom is tetrahedral 108 degrees. I hear your iPhones sending you emails. So, okay. Now, carbon has the ability to make lone chain carbon, lone chains of carbon atom. Do you know carbon was not able to do catenation? What is the catenation of carbon? The word catenation is used for ability of an element to bond to itself, make long chains, complex ways, all right? Now this one is the only element, can make that. Look at your faces, your proteins, all right? Do you know proteins are long chains of amino acids, right? And the polymers, things like that, because of the carbon has that ability. The alkanes, which I belong to. My last name ends with H, all right? So I'm Silivodian. So I'm not that explosive, right? The general formula is CnH2n plus 2. Somebody said boring. Alkanes are boring. Okay. Methane, ethane, propane, butane, pentane, you have to remember these prefixes. How do you name the alkane? All right. Can you see some memorization coming in the future? All right. That's me, okay? I get on board like that. Okay. What is the name of 6-carbon atom alkane? Hexane. 9-carbon atom alkane. No name. Okay, you got it. Okay. Okay, name, molecular content, and line formula of a straight chain alkane, saturated hydrogen and alkane. Okay, name, 4-carbon and alkane. N means normal, alright? Normal is straight chain. Branch chain means branches. Now, what is the name of this? Okay, you have to write name, molecular formula, condensed formula, and straight line formula for straight chain alkane. What is the answer to this question? What is the molecular formula? First one. C4. C4H N2 plus N. Right. What is the general formula?
H2N plus 2.
Right? What is that? 10, right? That's the molecular formula. What is the condensed formula? Now, a straight chain, middle of the chain always have what? CH2s. Terminal atom has. Condensed and line formula. Line formula. 1, 2, 3. Yeah. Okay. And we didn't have a structural formula. Okay, we don't have to write structural. All right, B. If the structural was, then you have to expand all these, right? Structural formula is this. Okay. Now number B. The problem is 7 carbon atoms is 7. What is that?
16.
16. 14 plus 2. Then what you write? CH2, 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 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. How do you write? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right? That's the line and chains. Okay, that's it. Now, last time I gave you on the next page, okay? How many of you have that? Okay, like I gave you. Okay, let me show you what I. Okay, we gone over this. Remember? On the other side, we have that. Okay? You have that with you? Okay. Now I'm going to go over this quickly. What is the IPAC name of the following branch alkanes? Now what you do is, in IPAC naming, this is really quick, okay? We don't want to spend too much time, but this is. Now, in alkanes, no problem. Normal alkanes. Butane, pentane, hexane. Now, in here, there's a branch here. You identify the longest chain. 1, 2, 3, 4, 5, 6. Therefore, hexane. But there's a branch at 3. 1, 2, 3. Okay? It's called 3-methyl hexane. 3-methyl. We don't call it 1, 2, 3, 4. 4-methyl hexane. We call it 3-methyl hexane. We give the lowest number, okay, to the branch, first branch. Okay? How many of you done that before? Okay. Some school do. Okay, this one is 1, 2, 3, 4, 5, 6, 7, heptane. 2, 3, 4, 5. 2, 3, 4, trimethyl heptane. Now you understand when you are naming branch alkanes, you use the longest chain, right? And then it's like a address, right? In a street, you have numbers, label there. So for example, mine is 2309. And my neighbor is about 2311. They put even numbers, okay? Because if somebody else comes in, in between, they build a house or something, so you need to have it, okay? All right. Now you understand how to name alkanes, branch alkanes. Man, what I did. Okay. Okay. Draw the structural formula of constitutional isomers with the formula there. With 4 carbon atoms. Now 4 carbon atoms, right? 4 carbon atoms could be bonded to straight chain or branch chain. That's the first alkane with branch chains. For example, when you put 3, you can put another one. Or this one. This one is called just butane. Other one is called isobutane. Butane. Now, what is a constitutional isomer? Constitutional isomer is 2 distinct molecules. The bonding is different. Therefore, their property is going to be different. Like a melting point, boiling point is going to be different. Like some conformational isomers, that means this rotation of hydrogen around the carbon-carbon double bond. They're not distinct isomers. Constitutional is like C2H6O. That could have this. That's called ether. This is C2H4. Ethyl alcohol and ether are 2 different molecules, but they have the same formula. Isomer is the molecule which has the same formula but 2 different structures. The bonding is different, right? So they are called constitutional isomers, right? They have melting point differences. Draw the condensed formula of constitutional isomer organic compound with this. You see that? Now, like I said before, alkyl groups, if you remove a hydrogen from an alkane, you open up a whole new series of compounds. You can, for that vacant bond, you can put a chloride, hydroxide, like alcohol, OH group, carboxylic acid group, COOH, like acetic acid has CH3COOH, right? Like a lot of other things. Therefore, it's very important to know this is propyl group. If you remove from propane, you can remove one of these or one of these. If you remove this, you get propyl group. If you remove on this, you get CH3, CH, CH, CH3. Now line formula of this, like this is the vacant bond here. But that one is, this is the vacant bond here. Now, propyl group and this isopropyl group is different, all right? So therefore, you can have different compounds, okay? The way you remove hydrogen to make an alkyl group, right, is very important. Now, next problem is, if an alkyl group like that, we put a OH group, we call it alcohol. It's called butanol. Butanol. Now, this is butane. How many carbon atoms? 4 carbon atoms. Carboxylic acid. This functional group, which changes the property of the alkane, is called carboxylic acid. It's called butanoic acid. Butane, butanoic. That's amine, like alcohol, amine, N-hexylamine. Then ketones. There's a carbonyl group stuck in between 2 carbon atoms. It's called butane, butanol, on, butan. This is not butane. 2-butanol. 2-butanol. Now, when you have like carboxylic acid, CHO group is called aldehyde. Okay? Now, similarly, you have to kind of understand there are molecular compounds with biologically important molecular compounds. This is called glucose. That's triglyceride. What is a triglyceride? Do you know what triglyceride is? You guys are young. You don't go to doctor yet, right? Get blood reports. Do you get any blood reports on your? If you have health problems, when you go to the doctor, they do a lipid profile. Lipid profile. Triglycerides are fats. So, for example, it's not good to have a lot of triglyceride in your blood. It has to be less than 150 or 200. That's the glycerol with carboxylic acid, long chain fatty acids. That's the glycerol. Glycerol is an alcohol. Amino acid. How many of you know what amino acid is? Amine group and NH2 group. They make the long chain, right? And how many of you know what is a fatty acid? Fatty acids are which are bonded to glycerol in the triglyceride. Fatty acids are saturated fatty acids or unsaturated. Saturated or unsaturated, which one is good? Unsaturated. The fat triglyceride with unsaturated fatty acids don't deposit on your blood vessels, right? So therefore they're good fats. All right. So we're done with this, okay? Now what I'm going to do is today, you have this one, like group homework 5, I send a piece of paper here. I'm going to do this, and you're going to do the quiz after you go home, okay? Well, I'm going to take 10 minutes to go over this, right?